Hi and good afternoon. We are going to finish lesson 8 and the last part of lesson 8 is pages between 215 to 221. So the topic is the reactivity of metals. We learn many things about transition metals. So this part is going to focus on the reactivity, those types of metal. So totally metals are very reactive, especially group 1 and group 2. Those metals are very reactive. Transition metals are less reactive than those two groups, but still transition metals are reactive and also very useful for many aspects, such as for extraction, such as studying on reaction with air or oxygen, or reaction with water, and reaction with dilute acids, and metal displacement reaction and redox reaction, which I explain more about this, and also can be investigated on heat stability of metal compound. All right, let's look at the extraction of metal. So unreactive metals, they usually they are pure and available in nature, like gold and silver and copper also. So they are unreactive. So therefore, they are not interested in combining with other metals or other compounds. They are interested in to be pure and with the same elements, and they are available. So on the other side, those metals which are very reactive, they like to react with the other compounds, organic, other inorganic, any compounds available, and then make a combination with the other elements, which is called ores. They are available in nature as a ores. So these types of combined actually compounds, they are required to be extracted. So they need to be separated. Another type, like moderately reactive, like iron, zinc, tin, and lead. So they can be combined with oxide or sulfates. So here there is one example, one sulfates ore that is quite noteworthy is iron pyrite, which because of its color become known as fool's gold. So iron pyrites is fool golds. And okay, this is one reaction here. You can see that zinc sulfate react with the oxygen because as I said, zinc is moderately reactive, so it's able to react with oxygen in air, then make a zinc oxide, and then also uh, the sulfate can be produced from the other side of this reaction. So if we provide a higher temperature as a physical condition for this reaction, then later we can use carbon to separate the metal. So now we have the mixture of zinc with the oxygens, which is zinc oxide. If we provide a carbon, carbon is playing a role as a role of reducing agent. So later I will explain again about the reducing and reduction and oxidation. So carbon can take the oxygen here and then produce carbon dioxide. then zinc will be alone and can be separated, because zinc in the previous reaction, zinc was react with made a combination with the oxygen. So but one purpose in dealing with the metal is extraction, as I said. So it's very important to extract and purify the metal for many applications like jewelry or windows frame, many things that we need. So here zinc oxide react with the carbon. Carbon is reducing agent. Reducing agent, that means removing oxygen. Oxidation agent means giving oxygen. Okay, there is another definition for this. Reducing, that means you reduce the electron. When there is oxygen, that means there are more electrons. When you reduce, that means you are removing oxygen or electrons. If you oxide any compound, any element, that means you give oxygen, or you can define as you are giving electron. So here carbon is reducing agent, that means carbon going to reduce or actually remove the oxygen from this zinc oxide. Then later as a product we will get zinc as a pure zinc, which is S, that means is solid, is pure, and then another product is carbon dioxide. So here a moderately reactive metal can be extracted by reduction with carbon, like this one, as I explained, like zinc. Here I said zinc, iron, tin, and lead, they are moderately reactive. So they can be separated, extracted from a carbon during the reduction process. And some metals are very reactive, they are too reactive, so they can be separated by electrolysis, like aluminium, magnesium, and sodium. So you can look at this table, like other one, potassium, and these type of metals which are very reactive, so they need to be extracted through electrolysis. We learned electrolysis in the previous chapters, if you remember. Another one is moderately reactive, that I've already explained. We need to use the carbon, and then another group can be unreactive totally, they are not reactive, so they are available based on the pure structure, like copper, silver, and gold. And another part, reaction of metal with air, water, and dilute acid. So in this type reaction, the two metals are in direct competition. When we have two, if there are two types of metal, they compete to each other to react either with water or air or dilute acid or whatever. So here sulfate or actually it's a kind of acid, which is sulfate hydrogen, a hydrate as sulfate can react with the copper. If we put zinc and copper in that dilute acid, then copper can react faster with the sulfate, but after a while zinc can replace with the copper here, then will produce a zinc sulfate, because there is a competition between copper and zinc is more reactive than the copper, so they will replace. And then copper can be extracted through this displacement reaction. So through this displacement reaction we can purify, actually extract some some metal. The one which is more reactive, they react with the other one, like water or acid, many things. Then the one which is less reactive, they can be extracted. So at the end of the reaction, at the bottom of the experiment glass, for example, you can get this copper as a solid form, um, which is left at the bottom of the reaction, but zinc is still combined with the acid, this in form of aqueous solution. So this is not a reverse reaction. We talk about the reverse reaction in uh, previous lessons. So it is possible to confirm the reaction series using displacement reaction for this type. Okay, later this copper, if we use this copper as a solid, is a solid form. Okay, if we use this copper to extract silver, we can do that. We can add copper to the solution of this. Actually, it's silver nitrates. Then, because copper is more reactive than silver, then the copper will react with the nitrates. Okay, nitrate solution. Then this one, the silver, can be extracted as a single structure, single element. Okay, another type is a redox competition reaction. Reactive metal are good reducing agent. So, yeah, I said that I will explain more about reduction and oxidation. However, we learned about these in previous chapters. So, the one which is more reactive, if we have more reactive metal, that means they tend to be more positive and faster, positive ion, which is cation, called cation, like here zinc. Okay, zinc can be how to say that, can be converted to zinc 2 plus plus. But the one which is less reactive, like copper, they receive instead losing the electron, they will receive electron because less reactive than the other one. So here we have zinc, which react with copper ion cation. Then zinc will be zinc cation, and then copper will be copper cation will be copper neutral elements. That means zinc is more reactive, and after a competition, zinc will be more positive than the copper. Copper will receive. The one which lose electron and becomes more positive is actually reducing agent. The one which gets electron like here copper, and become the neutral, like neutral elements, get electron. So that are oxidation elements. As I defined before, either we can define based on gaining or losing electron, or gaining or losing oxygen. Those are same concept. So here the atom of the more reactive metal lose electron, here like zinc, and become positive ion. Okay. And another example is here thermite reaction. So thermite reaction is happen on aluminum. Aluminum, the most reactive metal. All right. Then, for example, a reaction between iron oxide with aluminum. As we know, aluminum is more reactive. Then later, aluminum get the oxygen. That means receive the electron, and this one iron will lose the electron, lose the oxygen. Okay, so because aluminum is uh, more reactive. So okay, here thermal decomposition of metal compound. Okay, this shows that stability of a type of metal. Stability of certain metal compounds is related to reactivity of the metal. If the metal is stable, that means not reactive. Okay, reactivity is very poor. But if metal reactive, that means it's not stable, it's unstable. So here, for instance, most metal carbonates are decomposed on heating. If you provide a heat for the metal which is combined with the carbonate, like magnesium, so they will decompose it, decompose it here after giving heat. So then, as a product, you will get magnesium oxide and carbon dioxide because the compound will be broken. And another one, sodium, but one special case, sodium carbonate is stable on heat. It will not make like this decomposition. Okay, there will be not thermal decomposition for sodium carbonate only. And another one, metal hydroxide. Hydroxide or metal nitrates are unstable. There are two examples here, like magnesium with hydroxide, and another one is lead with nitrates here. Okay, after giving heat, they will produce different compounds with oxygen. That means it's very easy to be decomposite, but if it's stable like sodium carbonate, they will not um, they will not part in this reaction type of reaction. And this is also same for sodium and potassium hydroxides are stable. They will not produce they will not take a part of this reaction, but another type like potassium nitrate will take a part in this reaction. Another topic of this chapter, this lesson, is electrical cells and energy. So the one which is reactive, we learned about these electrochemical cells in previous chapter. So the one which is reactive, very simple, is reactive. They will produce more electric currents. For example, we have two copper two side, and of course there is a solution of electrolyte here. And as I said, we learned about the electrolyte in the previous chapter. You can refer back and memorize it. If we use the same copper, the competition doesn't produce any electrical current. But if we put one zinc here, which is more reactive with the copper, then it will produce more electron. The electric current will be stronger on the wire. Then you can see here. Also, if we if we change zinc to magnesium, which is more reactive metal than zinc, then electrical reactive will enhance again more and more, and these show you the voltage increase by about here based on this to about 2.7 volts, because the magnesium is more reactive than zinc. Alright, this is one experiment. Please keep in your mind this experiment, which can be important for your second paper in IGCSE exam. And oxidation and reduction in power cell. Here they just use a power cell as an example. to explain more about oxidation and reduction. Oxidation is losing electron here, like the zinc, and reduction is getting electron by here. So yeah, the copper electrolyte become positive terminal where electrons are removed and then gained by copper ion. Okay, that is for the definition of oxidation and reduction. So yeah, as I said, this can be defined based on gaining or losing electrons. Also can be defined based on getting or losing oxygen. So yeah, that's all for today. Please look at this question and try to submit your answer. Uh, so we are moving to another chapter 9, and we will start chapter 9 soon. Thank you so much. Stay safe and take care.